Well, you can see the Wairua water once it goes, our taniwha disappears. I mean, your Wairua's happy because the water's running now, but to me, I can feel it. The Wairua's starting to go because the water's declining.
This hour was very special for our whānau. We still try to collect our kai, our mahi and our kai in this area. It's not very healthy at the moment, but it's still a special way for us. They do our baptisms and stuff down there at the bridge. When it did really dry out, it wasn't quite nice to see, to be honest. Walking the dry riverbed and seeing, little pockets of water and seeing all these dead fish.
Well, we lost a lot of our kakapu, eels, stuck in holes. If you look at it in the Māori eyes, our river's actually crying, help me. That's what I can see, he's calling for help.
As part of this project, GNS Science has developed a national groundwater age model and also rapid model build tools that allow us to zoom in from that national scale to regional and local scales and build models in a much more cost-effective and rapid way so that they can be deployed to answer environmental management questions more quickly wherever they're needed.
Groundwater is hugely important for the region, particularly for the Heretaunga Plains and the Aotearoa Plains. So it's used for irrigation to help for horticulture. It's also used for drinking water, for town supply, but also for private supplies. We have a lot of industrial supplies that use the groundwater as well. And environmentally, it's really important for our spring-fed systems and also our wetland ecosystems. GNS have used the Heretaunga as a case study. So, a key strength for us is having those powerful numerical tools developed that we can use later to update for other simulations for groundwater management. But they also developed a bridge par model to try and investigate, the impacts on the Paritua stream and how different land use practices have affected the flow in there.
So we've focused in on that stream catchment and looked at all of the changes that have occurred since European settlement that have affected the stream flow and tried to untangle all of these different natural and man-made forces to work out what are the big levers in terms of turning that stream dry more frequently.
Models have become a common tool nowadays in terms of water management. I guess one of the things that have been missing for tangata whenua, mana whenua, of course, is the imbuing of our mātauranga into those particular processes, those tools to best manage water. So our philosophical base, our tikanga, our kawa is very important when you start to kind of pull a model together, that it does show itself being a part of this common tool to best manage water.
Mana whenua are really critical to the success of this project. The mātauranga that they bring is critical. They have different whakatauki and oral histories that relate very specifically to groundwater systems. Ngāti Kahungunu have these models themselves, these images of what groundwater systems look like based upon their knowledge of where the springs have emerged from the ground and how the rivers are flowing, the volumes in the rivers and how they all connect and link together.
My science part in the project is to build a groundwater model that's in part giving a numerical voice to the concerns of that community, as well as using all of the information available both from the Indigenous knowledge and also from data that the Council may have collected, and also more novel data, so the groundwater isotope data, which tells us the age of groundwater in an area and also where it's flowed from and the rate at which it's flowing through that aquifer system.
The recharge of the system was supposed to be from the Narororo River. So we looked into available data and wells, which basically we applied our tracer techniques. We got a very consistent picture that actually this part of the aquifer is not at all recharged by the Narororo River.
So we're hoping, the tools and results that come out from the Te Whakaheke Aotearoa program will help understand what should be done to manage flows, what sort of cuts are needed, would augmentation help, would riparian work offset some of these impacts that we're doing.
I think that we are in some ways reclaiming ourselves back into this particular space, as we've been left out of this space for quite some time. So this is an opportunity for Ngāti Kahungunu to step in alongside of this process. This information of Te Whakaheke o Te Wai is a serious contribution to enable that.
Having the scientists on board has been really good to prove that our water is kind of lacking, and we need to help this situation sustainably, hopefully, with the proof of science and also mātauranga Māori. I think that we can kind of work out a way that we can best nurture and look after this way. Yeah, I'm looking forward to seeing that journey.